Hello and welcome. I am Mr. Walid and I will explain another lesson, and it is called Permutations and Combinations. Actually, this lesson is much related to probability and statistics more than algebra and normal math. Before we start this lesson, there is a concept we need to know, which is called factorial of a number. So, what is the factorial? It is the multiplication of a number and what is less than number. So, for example, the general rule says a number, the factorial of a number, let's say it's called k factorial equals the number k itself times the number k minus 1 times the number k minus 2 and so on until you reach times 1. This is the smallest number we can reach in this multiplication, and it is 1, no 0. For example, the factorial of the number 4. What does it equal? It equals 4 times 3 times 2 times 1. So basically it is 4 times 3 is 12, 12 times 2 is 24, 24 times 1 equals 24. So the final answer is 24. And this happens for any larger or less number, except for the factorial of 0. Actually, the factorial of 0 can never be 0. We said the smallest factor can be 1. So that's what we can write for 0. The smallest factor is 1. We cannot write more than that. So factorial of 0 equals 1. Since we studied this already, let's move to the lesson of today, which is combinations and permutations. We are going to start with permutation. But first, they both are about counting the number of possibilities, the number of possible situations of something, like ordering something, some stuff. So the positions of that order, and so on. We will see for some examples later, but that's the main concept. So what is the difference if they are both counting the number of possibilities? So what is the difference between permutations and combinations? The basic and the main difference is that in permutations the order matters, and in combinations the order doesn't matter. What does this mean? We will see in a minute. Let's start with permutation. And as I said, in permutation, the order matters. So we can write that so that you permutations, the order matters. Sometimes the order matters. For example, if you are unlocking a locker, the combination in the locker is containing 3 numbers usually. So when you are opening, you have to put the numbers in order. You cannot put any numbers and the lock will open. So this is a case of permutation. Let's study an example. We will just know before we start the example that there are two kinds of permutation: permutation with repetition and permutation without repetition. So let's study the first case with repetition. And we will study the locker example now. So I will write the rule just right after we do the example. A locker or a lock contains 3 digits find the number of ways to open it. Okay, what is the number of ways to open this 3-digit locker? So it contains 3 digits. Okay, and we have options. Let me answer with another color. We have options to fill these 3 digits. Of course, we have the numbers from 0 to 9. From 0 until 9, this is 10 options. So the number of available options is 10. We have 10 digits to choose from: 0, 1, 2, 3, and so on until 9. Okay. We can fill the first by 1, for example, and the second by 5, and the third by 5 again. So repetition is allowed in here. So 155 can open that lock. For example, 666 can open that lock, and so on. So repetition in this problem is allowed. So when we fill the first digit, we have 10 options to choose from. And when we fill the second digit, again we have 10 options to choose from, because nothing is excluded, nothing is removed. Still the 10 options will be available. And again, for the third digit, we have 10 options to choose from. That's because repetition is allowed. So we do what? To find the number of all options, we time these to find the number of possible ways to open that locker, we have to multiply these numbers 10 times 10 times 10, which equals 1000. So in fact it is 10 times 10 times 10, which equals 10 times 10 times 10 equals 10 to the power of 3, which equals 1000. So we have 1000 ways to open, or we have to try 1000 times to open that lock, or there are 1000 ways to open to make a password for that lock. So let's reach a rule here. If this is the number of options, what will be these 3 digits? These are the number of chosen options. We have 3 chosen options here. So that's called the number of chosen options. Equals 3 choices. We have 3 choices. So number of chosen options is 3 and the number of options is 10. So this tells us that the total number of ways to open that locker or to try is 10 power 3, which is the number of options to the number of chosen options. Number of all options to the power of the number of chosen options. So that's the rule here. The permutation in this case, when we have repetition allowed, will be n to the power of r, where n is the number of r is the number of options. Sorry. N is the number of available options and R is the number of chosen options. Available options. R is the chosen, that's the number of. N is the number of available options. R is the number of chosen options. Okay. Another example so that we make it, and much simpler example than this. Three colors to choose from. Find the number of possible ways if repetition is allowed. So let's name these three colors like red, green, blue. So red, for example, green, blue. So the number of available options here is 3 options. طب let's adjust this problem. Let's choose two colors from these three colors. To choose two from, find the number of, so we will choose two colors from these three colors, only two. So we want to find how many possible ways to do that. Okay, I will do it without the rule and then I will do it with the rule to see if this rule is right. So without the rule, we are choosing two colors only. So, and repetition is allowed. So we can choose red, then red again. Okay, that's one way to do that. Then red and green. Then red and blue. That's a possible way to choose from. We will do that again with the green. We can choose green, then green again. Green, then red. Green, then blue. That's a way to start with the green. Now we can start with the blue and say blue, 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 red, blue, green. No more ways to choose from. Okay. I forgot to say that the order matters here because we are talking about repetition. We are talking about permutation. So I'm gonna write it that order here matters. What does this mean? That red and green is different than green than red. They are two separated events. We cannot consider them one thing. We have chosen first red, then green. Here we are choosing green, then red. So they are two distinct or two separated events. That's in case of permutation. But in combination, we will count them as one event only. So we will not talk about combination now. We will talk about permutation. The order matters, so they are considered like two separated events. So to count them, we have 3 here, 3 here, 3 here. So 3 plus 3 plus 3, which is equals to 9. So the number, the permutation in this problem is 9. Or the number of possible ways equals 9. Okay, now let's try to use the rule and save our time. If you want to use the rule, you have to find two things in this problem. You have to know the number of available options and the number of, which we will call it n, and the number of chosen options. So number of available options here are 3. We have 3 options. So n equals 3. And the number of chosen option is 2. We are choosing 2 colors from these colors. So the rule says permutation in this problem will be n power r, which is 3 power 2, which is same answer as 9. Okay, we usually use the rule if it is hard to list all the possible ways. Sometimes all the possible ways is too much to do manually, so we can use the rule and save the time. Okay, enough with permutation with repetition. Let's move to the other kind of permutation, which is, sorry, maybe I didn't show what was I saying. So here what I wrote, just in case next time I'm gonna look at the screen before I move. Okay, let's move on. to the other rule, which is permutation without repetition. Repetition is not allowed. So we wrote here 1, so we write 2. Permutation without repetition. We make the rule later, then in this case we are going to choose something, but once you choose it, you don't choose the same thing again. For example, find the number of ways to form a 3-digit number using these digits. Let's say we have 4 digits, 5, 9, 7, and 6. Okay, we have here 4 digits are the available options, and we are making a 3-digit number out of them. So we have 3 choosing options. So in this problem, I'm gonna show you first without the rule. Then I will write the rule and I will show you how to use it. Without the rule, we have 3 choices. And we have 4 options. We have 4 options. I should have said that first. We have 4 options. Let me call them R. Available options are equal 4. We have 4 options. And the number of choices or choosing options, which is n, equal 3 here. 3 choosing options will be put here. We cannot put 4. We are making 3-digit number. So we have 3 choosing options. Okay. Once you start, you have 4 options. So we have 4 digits to choose from and fill this first digit. We have either 5 or 9 or 7 or 6. I forgot again to say something here. Repetition not allowed. No repetition. So we have 4 options. Once we fill, for example, by 5, we can't choose it again. So when we go to the other digit, we don't have 5 anymore available because no repetition is allowed. If you fail by 5, you can't take it again. So there is less options now. We have 3 options, either 9 or 7 or 6. So here we can fail by 3 options. And same thing, if you choose, for example, 9, so 5 and 9 cannot be chosen again. So now you have to choose from 2 options. So here we have 2 choices or 2 options. Okay, how you get the total out of that? You time them together. So in this case, the permutation will equal 4 times 3 times 2, which will equal 4 times 3 is 12, 12 times 2 is 24. 24 ways to make. Of course, this will be a little bit long if you do it manually. So since we did that, now we can do the rule. The rule says n permutation r equals the permutation, the factorial of n over factorial of n minus r whole, or factorial of n minus r. We have n permutation r equal factorial of n over factorial of n minus r. Let's apply this rule here. So we say n here I have again messed up with the number of options is n, and the number of chosen options is r. Sorry for the confusion. So the n is supposed to be bigger than r usually, or maximum n equals r in some cases. So n usually bigger than r, and sometimes it is equal to r, but r cannot be never bigger than n. So the number of all the available options is 4, and the number of chosen options is 3. So n equal 4 and r equal 3. So we can say like this way. If you use this rule, you say 4 permutation 3 equals the factorial of 4 over the factorial of 4 minus 3. So that's going to be factorial of 4 over factorial of 1. Of course, factorial of 1 is 1, so this is going to be basically 4 times 3 times 2 times 1, which is the same answer, 24. Okay, let's do another example about the permutation without repetition. And let's take the colors problems. I start usually with order. So 3 colors again to choose 2 from, and repetition, order matters, repetition not allowed, find the number of possible ways. Okay, we will name these colors again. We will do them manually if we can, and then we do them with the rule to check if it is right or wrong. So let's name these 3 colors: red, green, and blue. We are choosing 2, and order matters, so it's permutation and there is no repetition. So red, then red is not allowed. Repetition not allowed. So we say red, then green. Red, then blue. Green, then green is not allowed. So we say green, then red. Green, then blue. And blue, blue is not allowed. So blue, red, blue, green. So we have 6 ways to do that, and we cannot say blue then red is the same as red then blue. These are 2 separated events. We count each one alone because the order here matters. Blue then red is different than red then blue. In combination, it doesn't matter. We will consider them as one thing. So the permutation here equal 6. Now let's do the rule to see if 6 is right or wrong by the rule. So by the rule, we have n, which is all the number of options available. Here is 3 options, and r is the number of chosen options is 2. We're choosing 2 colors, so it's going to be 3 permutation 2, which equals factorial of 3 over factorial of 3 minus 2. This is going to be 3 times 2 times 1 over 1. So this is going to be 6. Same answer we found before. Okay, let's do a question that we cannot do manually. And three meals. Okay, no, not 3 meals. Let's say 8. Okay, 8 boys is a group. We have a group of 8 boys, and 3 boys are chosen randomly find the number of possible ways if the order matters. Okay, if you want to do this manually without the rule, it's going to take long time. Why? Because you have to give names for these boys like A, B, C, G, E, F, and so on, 8 names, and then you make all the possible ways to choose 3 boys from them. So, and here is no repetition. Why? Because if you choose one of them from the 8, you will not choose him again. So the number of available options is 8, and the number of chosen options r equals 3, and it is a permutation problem because it is mentioned that the order matters. So we will say 8 permutation 3 equals, just like the rule says, factorial of 8 over factorial of 8 minus 3, which will be factorial of 8 over factorial of 5. This is going to be factorial of 8. We can simplify. I will teach you how to simplify the division of factorials. The factorial of 8 is 8 times 7 times 6 times 5 factorial. When you reach 5, you stop and say the 5, because the factorial of 5, you continue 5 times 4 times. Why am I stopping on 5 and making factorial? Because I'm going to divide factorial of 5, divide factorial of 5, they are cancelling each other. Anything divide itself equals 1. So actually this will be 8 times 7 times 6 only. So you can calculate this by the calculator or by head if you're good in multiplication. 8 times 7 is 56, and that's 56 times 6. The answer will be 336. Of course, that's a big number. If you want to try, you will have to try many. You can take 2 pages to do that. So the rule made it in 1 line only. Okay, so we have 336 ways to choose from. By the way, in the calculator there is a way to find the factorial, which shifted in this button. You see in yellow. So we can say 8 factorial over 5 factorial. But I really don't like to use a calculator in finding these questions. Better safe than sorry. Okay, since we know now how to use the rule in permutation with repetition and without repetition, so I will just remind you, with repetition, P equal n to the power of r. N is the number of available options, r is the number of chosen options. Okay, that's in case of repetition. And in case of permutation without repetition, the rule is n permutation r equal the factorial of n over the factorial of n minus r. Okay, and n is the number of available options, r is the number of chosen options. Let's move on to another thing, which is combination. And as I said in the beginning, combination is when the order doesn't matter. So the second thing is combination. And the order in combination doesn't matter. Okay, I will start in combination without repetition. And why? I'm gonna say in a minute why. So, first thing, combination without out without repetition. Let's leave the repetition in combination because the rule is a little bit more complicated. So without repetition is easier, the rule. Of course, I will not write the rule now. I will just write an easy example. Then we will write the rule. Let's go to the problem of colors. 3 colors again. To choose 2 from. Find the number of possible ways. Okay, the order doesn't matter and no repetition. Okay, let's do that. Start that. We have to name them like red, green, blue. So red is not allowed. Red green, red blue. Okay, green is not allowed. Green red, green blue. Okay, blue is not allowed, so blue red and blue green. All right, the order doesn't matter. If you choose red then green, it is the same thing if you choose green then red. So in fact these two are one event, one thing. We can cancel one of them, and red blue is the same as blue red. This is one thing, and same thing for green blue is the same as blue green. That's one. So in fact we have 3 ways here. So that's combination. The combination here equals 3. We have 3 ways to do that. That's usually the combination is smaller in the outcome than the permutation, because we are cancelling the repeated ways, or the order doesn't matter here, so we are cancelling some events. Anyway, what will be the rule if we want to use the rule? The rule says the n combination R equals the factorial of n over factorial of R times factorial of n minus R inside the bracket, like that. So we want to use the rule here. What's the n? N is all the available options, which is 3. R is all the number of chosen options, which is 2. So we say 3 combination 2 equals, we make a line, fraction line. Up is the big number, the 3 factorial, over the small number down factorial, 2 factorial, times 3 minus 2 all factorial. Okay, this is gonna be 3 factorial times, sorry, over 2 factorial times by 1 factorial. 1 factorial is 1, so it's going to be 3 factorial over 2 factorial. I told you the trick to do simplify that will be 3 times 2 factorial over 2 factorial, factorial of 2 down, factorial with 2 up will be cancelling, so the answer will be 3, which is the same thing we got here. Okay, let's do a question about that when we cannot do it manually, like the group of 8 boys that we did before. We will do it here again, but the order doesn't matter, so that's the right thing to do with the group of 8 boys. The order doesn't matter, but I wrote it the order matters before so that we can use it with permutation. Okay, I will write the question again. A group of 8 boys, 3 are chosen randomly. Find the number of ways. Of course, here repetition is not allowed. We cannot choose the same person again. Once he's chosen, someone is chosen, will not be chosen again. So we don't have to write the obvious. Okay. And here the order doesn't matter. And we don't have to write that also. The order doesn't matter. If you choose someone and another one, it doesn't matter who was first and who was second. So also we don't have to write the obvious here. So that's the order doesn't matter. That's a combination problem and no repetition. So this is combination without repetition. You have to know what you're doing. Okay, n, which is the number of available options, equals 8, and r, which is the number of chosen options, is 3. So we are finding 8 combination of 3 using this rule, which is factorial of 8 over factorial of 3 times factorial of 8 minus 3. That's gonna be factorial of 8 over factorial of 3 times factorial of 5. Okay, we can simplify factorial of 8 by 8 times 7 times 6, and then we stop at 5 and write factorial. We can write 3 as 3 times 2 times 1, and then times factorial of 5. Leave it as this to simplify up with down. This with this is gone, so we just have 8 times 7 times 6 divided by 6. 6 is gone with 6, so it just became 8 times 7, which is 56. You can use the calculator to find that, but that's the right answer. 56 ways to choose from. That's much less than we found before that the number was big, because I said the order matters. Here I said here the order matters, so that was a permutation problem. So as you see, 8 permutation 3 is bigger number than 8 combination 3. 336 is significantly bigger than 56. So same problem, but this is permutation, this is combination, and we found out the difference in this. I will do another last question about combination. without repetition. A coin tossed 6 times. Find the number of getting head 2 times in the 6 times of getting head, let's say 3 times. In the 6 times that we throw the coin, we want to find the expected number of getting the head 3 times. This is a question about probability usually, so it should be find the probability of getting head, not the number, probability. The probability of getting hit 3 times. What is the chance of getting hit 3 times if you're throwing the coin 6 times? Okay, the manual way here is a little bit big, but I'm gonna show you by a quick way. In the first time, you will make a tree diagram. The first time you will throw, you can get head or tail. That's the first trial. Then the second try, I'm going to do what is called tree diagram. Then the second time you have if you have head in the first time, you might have in the second time head or tail, and same thing for tail, head or tail. Okay, that's second time. Third time, same thing, head or tail, head or tail, head or tail, head or tail. Fourth time, same thing, head, tail, head, tail, for head, tail, head, tail. I should have made it bigger. Head, tail, head, tail, head, tail. Fifth time, you can continue this by yourself, so that I don't want to waste the time with you. In the end, you will count the number of in the total number of possible ways. It will be 6 to the power of 2. It will be the 6 times to the power of the 2. Will be 6 power 2 equal 36. What is the 6? The number of the trials. What is the 2? The number of options, or the number of faces on the coin is 2 faces, head or tail. So that's the number of options, and down here is the number of the trials. I'm gonna write that the trial to the power of the number of trials to the number of the possible outcomes in any trial of them. In any trial there are two outcomes. The T is the number of trials, and the R is the number of outcomes in each outcome in each trial. Okay, this is much related with the lesson of probability, which is not our subject name. Okay, you will count when you reach 6. You can continue by yourself with this diagram. You will find in the end 36 outcomes or 36 possible ways. Okay, there are two ways to find the getting the head 3 times. You count how the tree that comes the head 3 times, like head, then everything tail. So you can count how many head, 2 heads only. Okay, you start with here the head, tail. It is a little bit long, so we can use combination to make it short way. So you say to me, how do you do the combination here? What will be the number of available options? N equals 6. Okay, what will be the number of the chosen options? We are choosing the head 3 times, so the number of chosen options here will be 3. This R is different than this R. I should have named this like K. Okay, so that it becomes different. So K is the number of outcomes here. It's a lesson with probability. Okay, so the number of options is 6 and the number of chosen options is 3. We are choosing 3 heads and we are using the combination, so we can say 6 combination 3 equal factorial of 6 over factorial of 3 times factorial of 6 minus 3, which is factorial of 3 again. So this factorial of 6 over factorial of 3 times factorial of 3. So 6 can be simplified to be 6 times 5 times 4 times factorial of 3. We're stopping because we're canceling over factorial of 3. This will be cancelled with this, and this other 3 will be 3 times 2 times 1. So this with this 6 with this 6, so it's 5 times 4 only, which is 20. So there are 20 ways to get the head 3 times. There is 20 ways to do that. Okay, you will get tired if you count the 20 ways from here. Head, tail, and tail, head, and there are so many in the middle. So there are 20. This is much simpler. So the probability, as you know, is the number of events over the total number of events. The number of events here is 20 over the total number, which is 36. So we say probability of getting 3 heads will be 20 over 36. So 20 chances out of 36 chances to get that. We can simplify, you can change to percentage, you can do whatever, but this is the probability. Okay, now the last thing is coming now, which is combination with repetition. So second, with repetition. As usual, I will not write the rule. I will just make a little example, then I use the rule to do check. I like to use the rule only with if I can't do it manually, as you know. Okay. The colors again. 3 colors to choose 2 from. Find the number of ways if repetition is allowed and the order doesn't matter. Doesn't matter means the order doesn't matter, it is combination, and the repetition is allowed, so it is combination with repetition. Let's name them green, blue, and red. Okay, so I'm choosing 2 colors. Green is okay, repetition is allowed. Green, blue, green, red, blue, green, blue, red, then red, green, red, blue. Okay, we are allowed to repeat. Okay, the order doesn't matter, so we are canceling some events here. Green, blue is exactly the same as blue, green. So these two, they are one thing, and that's one thing. And green, red, same as red, green. Blue is one thing again. Okay, how about blue, red, blue are one thing. Okay, red is one thing. So why blue, red, and red, blue are one thing? Because here the order doesn't matter. Okay, this is not permutation, it is combination. They are same thing. So we count here 1, 2, 3, 4, 5, 6. So the combination here equals 6. 6 ways to do that. Let's see if that is the same answer we got before. Here was 3 ways only. Okay, no repetition was allowed. And you can see in permutation what is equal before. So let's just continue here and do the rule because the video became a little bit long this time. So the rule says what? The combination and combination are equal. And it is a little bit unusual rule not written in many books I saw, but anyway, we are going to write it down. So bracket r plus n minus 1 all factorial over r factorial times bracket n minus 1 factorial. So we wanted to use this rule here. What shall we do? First, you have to find the n, which is the 3, all the available options, and r is the number of n is 3, r is the number of chosen options, which is 2. So in this case, 3 combination of 2 will equal, we will use the rule, the other rule here, which is gonna be 2 plus 3 minus 1, bracket 2 plus 3 minus 1 factorial over 2 factorial times 3 minus 1 factorial. Up will be 2 plus 3 is 5, 5 minus 1 will be 4 factorial over 2 factorial times 2 factorial. The answer of that will be 2 times, 4 times 3 times 2 factorial over 2 factorial times 2 times 1. This 2 up factorial cancelled with that. So we can say the answer will be 4 times 3 divided by 2. 12 divided by 2 equals 6, which is the same answer we got here. This is the same like this. So I thank you for your patience to watch this whole video, and I wish you understood. And as usual, you can tell me any lesson you don't understand in the comments, and I will try my best to explain it. Thank you. See you.